In this video, we're going to solve the Calculus 2004 Calculus AB FRQ question number 5. So it says the graph of the function f shown above consists of a semicircle and 3 line segments. Let g be the function given by g of x equals the integral from -3 to x f of t dt. So it says find g of 0. So now if we find g of 0, we need to basically find the area underneath the curve. So now I'm going to write, this is part A, g of 0 is going to equal -3 to 0 f of t dt, which is going to be the area of, let me do this like a trapezoid, this little area right here. So now when I find this, it's going to be positive because it's above the x-axis, 1/2. What's the width? 1, 2, 3, 3 sideways, 2 plus 1, which is going to equal 1/2 times 3 times 3, which is 9/2. Okay. The second part of the question says find g prime of 0. G prime of 0 is just going to be f of 0, which is 1. It's whatever this value is right there. Let me do a little arrow. Okay. Part B says find all values of x in the open interval -5 to 4 at which g attains the relative max. Justify your answer. Now, g of -5 could be 1 if it wasn't a parentheses, because that's an endpoint and it's traveling downward. But the fact that it did that, we can't do that. So the only place that's going to work is going to be where the slope changes from, and it wants a max, right? A max. So a max would be where the slope changes from positive to negative. So it has to be there at g of 1, 2, 3. G of 3 is a relative max because f prime, or f of x, I'm sorry, not f prime, f of x is greater than 0, then f of x is less than 0. Okay, part C says find the absolute minimum value of g in the closed interval from -5 to 4. This is closed, so now we have to use EVT, so the endpoints. G of -5 could be 1. So g of -5 is going to be from -3 to -5 f of t dt, which is going to equal well, let me switch the signs. -5 to -3. Put the negative here, f of t dt. I don't think that's going to make a difference because the areas look like they're the same. So let's use a green color. So this area looks to be the same as that area. So now when we do this, we have the negative 1/2, 2 times 1, minus 1/2, 2 times 1, which is equal to 0. So g of -5 is 0. I could have told you right now that that's a relative max because it starts at an endpoint and it goes up. Okay, so now we need to find the next point, which is going to be g of -4. G of -4 is the area from -3 to -4, f of t dt, which is good because we already kind of found this in the previous part. So negative, let me switch the boundaries, -3, -4, -3, f of t dt, which is going to equal -1/2, 2 times 1, which is equal to -1. The last point is the last endpoint because all the other ones are maxes or wannabes. So you go to G of 5, G of 4, not G of 5, G of 4. That's the last endpoint, which is going to be negative 3 to 4 f of t dt, which is going to equal from negative 3 to 0 f of t dt, and then 0 to 4 f of t dt. So now when we do this piece, we already know that this is 9/2 because we found it here. Plus. Now, when you look over here, this is really a rectangle and a semicircle. So we have this shape right here. So we need to do this. Find the area here and then subtract the semicircle. Not my best drawing, but I think you get the gist. So it's 2 times 2 minus semicircle 1/2, 1 squared, pi. So this is a rectangle minus a semicircle plus the area of this little triangle, which that looks like it's going to be the same as this triangle. So that's going to be 1/2. What is that? 1 by 1? Yeah, 1 minus 1/2, 1 by 1. So these cross out. So now we're going to get 9/2 plus 2 by, oh, this should have been a 1, not 2 by 1. This is a 1. It's 2 by 1. So 2 minus 1/2 pi, or pi over 2. When you get the same denominator, now you're going to get 13/2 plus minus pi. Okay. Part D says find all values in x in the open interval from -5 to 4 at which g has a point of inflection. So point of inflection is where the slope of the slope changes direction. So one point is definitely -3. This is a wannabe. It's negative then negative. 2 appears to be 1. And 1 also appears to be 1. Let me switch colors because I don't think you can see that. I'm going to use a blue. Okay, so this is a point of inflection. That point right there. This is a point of inflection, and that's a point of inflection. So when you do this, you would say g of -3. You would also say g of 2 and g of 1. So g of 1 and g of 2. The reason is f double prime switches from greater than 0, then f double prime switches to less than 0 at that point. For g of 1, the slope is negative, then positive at that part of the semicircle, so f double prime switches from less than 0, then greater than 0. And g of 2 is going to be the same reason as g of -3. So I'm just going to move this a little bit so I have a little bit more real estate. So now g of 2 is going to be f double prime is greater than 0, then f double prime is less than 0. I hope this video helped.